Yeah, please take out this paper. We are doing May June 2024, and this is your May June 2024 का paper. This is variant 1. This is variant 1. ठीक है. Please take out this paper. Let's start with this paper. Okay, so let's see this. This is paper 4, variant 1. Some constants, and yeah, let's move on to the first question. Define the term gravitational potential. Yes, you have to define the term gravitational potential. Any geniuses in the chat? You have to define the term gravitational potential. How will you define it? Work done per unit mass. Work done per unit mass in moving a mass from infinity to any point in the gravitational field. बेटा बहुत ही easy definition है. What will you write here? Work done per unit mass in moving a mass from infinity from infinity to any point in the gravitational field. Work done per unit mass in moving a mass from any point from infinity to any point in the gravitational field. Perfect. Nothing complicated. Let's further move ahead, bhai. Let's further move ahead. एक second. Yeah. ठीक है. चलो. A satellite X of mass m. Okay, so we have a satellite X of mass m. Where is the satellite? Here. At a radius of 4r. Perfect. You are at a distance of 4r from the center of the planet as shown in figure 1.1. Perfect. A second satellite Y of mass 2m. Okay, a satellite Y of mass 2m orbits the planet with a radius of r. Perfect, perfect. The gravitational potential at x due to the planet is negative phi. Okay, so the gravitational potential at x is negative phi. Perfect. The planet is a uniform sphere. Perfect. Explain why the gravitational potential at x is negative. Now, this is the most beloved question of the examiner. Beta, examiner loves this question. Each year, this question gets repeated. This is an FAQ. This is an FAQ. Usually, it is of 3 marks, but here it is of 2 marks. I don't know why it is of 2 marks. Explain why gravitational potential at x is negative. Okay. So there is a 3-pointer answer to this. Why is gravitational potential negative? The first point that you will write here is, yeah, you can say that, but थोड़ा सा इसको keywords की form में लिखना होता है. First of all, you will say gravitational potential. Gravitational potential at infinity is 0. This will give you the first mark. Gravitational potential at infinity is 0. What will your second mark be? Gravitational forces are attractive. Gravitational forces are attractive. The third mark, although this is a 2-marker question, but I am giving you an answer for a 3-marker. The third mark will be dependent on what? Work is done on the masses in moving them far apart. Work is done on the masses in moving them far apart. Work is done on the masses to move them far apart. To move them far apart. Simple as that, nothing complicated here. Let's further move ahead. Hmm. You can say that as well. Very good, Aleha. I think you remember जो मैंने क्लास में लिखवाया था. Very good, very good, very good, very good. चलो. State an expression in terms of y, in terms of phi, for the gravitational potential at y due to the planet. Wow, what a beautiful question again. Okay. Okay, so let's see this question. State an expression in terms of phi for the gravitational potential at y due to the planet. Perfect. So let's say the mass of the planet is mp. Perfect. We know that the gravitational potential at x is what? The gravitational potential at x is negative phi. Let's label that here. The gravitational potential at x is negative phi. And this negative phi is equals to what? Minus capital G, mass of the planet, divided by the distance, that is 4r. Do you remember that the formula for phi was what? Minus capital G, capital M divided by the distance between the planet and the satellite. Simple. Now, if you analyze satellite Y, if you analyze satellite Y, what will be the gravitational potential here? What will be the gravitational potential at Y? The gravitational potential at Y is equals to negative capital G, mass of the planet, divided by the distance, that is r. Divided by the distance, that is r. Now, if you are a good thinker, you will do one thing. Let's take this 4 to the left hand side. Negative 4 phi is equals to capital G, mass of the planet, divided by the distance r. Okay. If you analyze this negative G, mass of the planet, divided by r is equals to what? This negative G, mass of the planet, divided by capital R is equals to what? This is equals to the phi at point Y. So what can you do? You can simply, what can you do? You can simply replace minus 4 phi in terms of this. Okay, let's do that. Let's do that. Let's do that. Phi of y is equals to minus 4 phi. Why did I did that? Because I realized that negative capital G, mass of the planet, divided by r is equals to what? Negative 4 phi. Can you analyze this? This negative capital G, mass of the planet, divided by r is equals to negative 4 phi. Hence, here you will say that gravitation potential at y is equals to negative 4 phi. Let's further move ahead. Now you have to determine an expression for gravitational field strength due to gravitational field strength at satellite due to the planet at satellite X. Okay. So now we have to calculate the gravitational field strength at point X. Okay. At satellite X, you can say that. How will we do that? Let's take a blue color to maintain consistency. What was the formula for gravitational field strength? Do you guys remember? What was the formula for gravitational field strength? Gravitational field strength was equals to capital G, mass of the planet, divided by the distance between the planet and the satellite. That is 4r square. Perfect. If you realize gravitational field strength is equals to what? Capital G, mass of the planet, divided by 4r into 4r. Simple. Now, if you realize one thing, what is this capital G, mass of the planet, divided by r? If we know, negative of phi is equals to negative capital G, mass of the planet, divided by the distance 4r. Cut. Phi will be equal to what? Capital G, mass of the planet, divided by 4r. So if you realize, you can substitute this capital G, mass of the planet, divided by 4r with what? Phi. Gravitational field strength at x is equals to phi over 4r. Let's write it down. Gravitational field strength at point x is equals to what? Phi over 4r. Now let's do the same thing for satellite Y. Let's do the same thing for satellite Y. I think I will have to, no, I don't have to remove anything. Let's calculate the gravitational field strength at satellite Y. The gravitational field strength at satellite Y is equals to the gravitational constant multiplied by the mass of the planet divided by r square. Can you write it like this, that gravitational field strength at Y is equals to capital G mass of the planet divided by r into r? Yeah, can you write it like this? Yeah. If you humbly realize this capital G mass of the planet divided by r is equals to what? Hmm. Capital G mass of the planet divided by r is equals to what? Is equals to the phi at y. So gravitational field strength at y is equals to what? Phi of y divided by r. Now there is a problem. Now there is a problem. If you analyze, there are two problems actually. There are two problems actually. First of all, you can say that positive of capital G mass of the planet divided by r is equals to negative phi. Why? Why am I saying this? There is a little complication here that I want you to understand. Can you realize this is negative capital G mass of the planet divided by r? If I take the negative sign towards the left hand side, phi of the planet y is equals to capital G mass of the planet divided by r. So you will put a negative here. You will put a negative here. Now there is one other problem. There is one other problem. Can you realize that you only have to give the answers in terms of mass, r, and phi? The term gravitational potential of y is not included here. The term gravitational potential at y is not included here. What are you going to do? You will replace this gravitational potential at y. You will replace this gravitational potential at y with what? You will replace this gravitational potential at y with negative 4 phi. You will replace this phi with negative 4y, negative 4 phi. So negative 4 phi divided by r. Your gravitational field strength at y comes out to be 4 phi over r. Simple. Let's write it down. Let's write it down. The gravitational field strength at y is 4 phi over r. Simple. I think we have, yeah. So up till now, there are 2 to 3 important results that we need to encircle. This one, and which one is necessary? This one, and maybe this one. Gravitational field strength at y. Simple. Now we have to calculate the gravitational potential energy of the satellite at satellite X. We have to calculate the gravitational potential energy at satellite X. What is the formula of gravitational potential energy? Gravitational potential energy is equals to what? Negative capital G mass of the planet multiplied by the mass of the satellite divided by the distance between them, that is 4r. Now if you realize what is negative capital G mass of the planet divided by 4r equal to? What is negative capital G mass of the planet divided by 4r equal to? It is equals to negative phi. So can we replace this entire thing with negative phi? Yeah. Gravitational potential energy at satellite X is equals to what? Negative phi into mass. So this is one more result that you can put in a box here. Let's write it here. The gravitational potential energy is equals to mass into phi. Simple. Now let's calculate the gravitational potential energy at satellite Y. How are you going to calculate the gravitational potential energy at satellite Y? Very, very easy. The gravitational potential energy at satellite Y is equals to what? Minus capital G Mass of the planet, okay, multiplied by the satellite's mass, that is 2m, divided by the radius, that is 4r. That is r. Sorry, my bad. My bad. I am really bad at it. So if you realize negative capital G mass of the satellite divided by r is equals to what? It is equals to what? It is equals to what? Can you realize here? Negative capital G mass of the planet divided by r is equals to what? Negative 4 5. Simple. Put it here. Negative 4 5. And what further can you do? You can multiply it with the mass 2m to get your final answer as minus 8m phi as your gravitational potential energy at satellite Y. Let's write it here. Let's write it here. Minus 8m phi. Simple. This marks the end of this question. 1 second यार हाँ everyone 1 second हाँ ठीक है. State the magnitude and unit of absolute zero on the thermodynamic temperature scale. Perfect. हाँ हाँ मैं दे दूंगा क्लास के एंड पे ठीक है. ओके व्हाट इज एब्सोल्यूट जीरो. एब्सोल्यूट जीरो इज 0 केल्विन 0 K. ठीक है. डोंट वरी अबाउट दैट. अभी सिर्फ जो मैं नेक्स्ट क्वेश्चंस कर रहा हूँ उस पर फोकस करो. Thermodynamic temperature is in terms of thermodynamic temperature what is absolute zero. 0 Kelvin or 0 K. Okay. Now let's further move ahead. Explain why temperatures measured using a laboratory liquid and glass thermometer does not give a measurement of thermodynamic temperature. Yes. Beta, when we use a laboratory liquid and glass thermometer, why does not it give a measurement of the thermodynamic temperature? Always remember there's a small little key point. Do we have a blank page area? Always remember glass thermometers, liquid in glass thermometers, liquid in glass thermometers are what? They are based on properties of a real liquid. They are based on properties of a real liquid. Liquid and glass thermometers are based on the properties of a real liquid. Liquid and glass thermometers are based on a property of a real liquid. If you need a thermometer that measures thermodynamic temperature thermometer, what will you want? You will want the liquid inside to be ideal, is based on properties of an ideal liquid, is based on the properties of an ideal liquid. So this is the reasoning. मैं क्लास के एंड में कर देता हूँ वहां मैं क्लास के एंड में कर देता हूँ बेटा. लेट मी एक्सप्लेन इट एट द एंड. ठीक है. Liquid and glass thermometers are based on properties of a real liquid. Thermodynamic temperature are based on what? They are based on the properties of an ideal liquid. So what will you write here? Why does a liquid and glass thermometer does not give you a thermodynamic temperature reading? Why? Because it depends on the properties of a real liquid. Because it depends on the properties of a real liquid. Let's further move ahead. Figure 2.1 shows a simplified diagram for a type of thermometer called a platinum resistance thermometer. Okay, so this is a platinum resistance thermometer. This is a platinum wire. Okay, you have a plastic strip. Okay, you have a large glass tube. Okay, the glass tube is immersed in the environment for which the temperature is to be determined. The resistance between terminal X and Y is measured. Perfect. The resistance between these two terminals X and Y is measured. Perfect. Figure 2.2 shows the variation of the resistivity of the platinum with the thermodynamic temperature T. So this graph is basically showing what? Resistivity versus the thermodynamic temperature T. Perfect. This is your graph. Explain how figure 2.2 show that platinum is a suitable metal for use in a resistance thermometer. Why is platinum suitable for use in a resistance thermometer? Can anyone tell me? Why is platinum suitable for usage in a resistance thermometer? The first thing that you can see here is resistivity is varying with temperature. Yep. Waha, very good. If resistivity is varying with temperature, it is suitable for use. Why? Because as the temperature will change, resistivity will change. We can easily measure that. Second thing that is very interesting or very useful for us is that the variation in temperature is linear. The variation of resistivity and temperature is linear, simple. So you can write it here. Platinum is a suitable metal for use in a resistance thermometer. Why? Because the resistivity varies with what? Varies with temperature. Second of all, second of all, the variation of resistivity resistivity with temperature is linear. With temperature is linear. Perfect, nothing complicated here. Sir, is linearity compulsory? But it is not compulsory. But can you see this is a two marker question? So we have to write two advantages of using platinum. Suggest a reason why platinum is not suitable for measuring rapidly changing temperatures. Why is platinum not suitable for measuring rapidly changing temperatures? Yes. Any geniuses in the chat who would like to answer this? Why is platinum not suitable for measuring rapidly changing temperatures? Yes. Yes. Can you see this is a typical thermometer? Yes, there is a delay. Rafe, good. Very good. There is a delay for the thermometer to reach the correct temperature. You will say there is a delay or thermometer takes time to reach the correct temperature. Let's further move ahead. State a type of thermometer that is suitable for measuring a rapidly changing temperature. Yes. Which thermometer can we use to measure a rapidly changing temperature? Thermocouple. Thermocouple can be used to measure a rapidly changing temperature. Basic O levels IGCSE physics. Let's further move ahead. A negative temperature coefficient thermistor may be used as a type of resistance thermometer. Perfect. State one way in which the variation with temperature of the resistance of a thermistor differs from that of a platinum wire. Okay. Now you have to realize one thing. Why has the examiner written negative temperature coefficient thermistor? Why has the examiner written this and especially this negative covered? Why has this examiner written this negative covered? This negative temperature coefficient basically means that as temperature will increase, your resistance of the thermistor will decrease. As your temperature will increase, your resistance of the thermistor will decrease. What is happening in the platinum thermometer? As the temperature increases, resistivity increases. This is sort of a direct relationship. This is sort of a direct relationship. What is this? This is an inverse relationship. This is an inverse relationship. So you can write it here. State one variation with temperature of the resistance of a thermometer. Okay. The temperature and resistance of thermistor, resistance of thermistor vary inversely. Vary inversely. Is everything clear? Yes or no? Hmm. Is everything clear, beta? Sir, is my reason correct? Temperature increases resistance. You can say that. You can say that. State what is meant by an ideal gas. What is meant by an ideal gas? Any gas which follows with what? Any gas that follows the equation PV is equals to nRT for all values of pressure, volume, and temperature is known as an ideal gas. So any gas that follows PV is directly proportional to temperature for all values of pressure, volume, and temperature is known as an ideal gas. Perfect. Chalo, let's further move it. Use one of the basic assumptions of the kinetic theory to explain what can be deduced about the potential energy associated with the random motion of molecules in an ideal gas. Do you guys remember that in an ideal gas, your potential energy was zero? In an ideal gas, the potential energy for an ideal gas is zero because there are negligible, there are negligible intermolecular, intermolecular forces of attraction. Simple as that, nothing complicated here. Okay, let's further move ahead. A sample of 0.26 meter cube of an ideal gas is at a pressure of this. This is your volume. This is your pressure. This is your temperature. Can you calculate the number of molecules of the gas? Yes. Do we remember this formula? PV is equals to capital NKT. What is pressure? 2 into 10 raised to the power of 5. What is volume? 0.26. We have to calculate the number of molecules divided by K. That is the Boltzmann's constant, 1.38 into 10 raised to the power of minus 23 multiplied by temperature, that is 290. Can you tell me the number of molecules of the gas? Can anyone tell me the number of molecules of the gas? The number of molecules of the gas come out to be what? 1.3 into 10 raised to the power of 25 molecules. 1.3 into 10 raised to the power of 25 molecules. The average kinetic energy of one molecule of the gas. How can we calculate this? Average kinetic energy is equals to 3 over 2 kT. What is K, Boltzmann constant? What is temperature? 290. Can you calculate the kinetic energy? Yes or no? Calculate it, please. The kinetic energy comes out to be 6 into 10 raised to the power of minus 21 joules. Simple as that. You have to calculate the internal energy of the gas. You have to calculate the internal energy of the gas. How will you do that? Very, very easy. The internal energy of any object is equals to what? Potential energy plus kinetic energy. But since this is an ideal gas, the potential energy will be zero. the internal energy will only be equal to kinetic energy. Now, most students will just write this kinetic energy. Most students will just write this kinetic energy and will leave the question. But they fail to notice that this is the kinetic energy of one molecule. Here you have to calculate the internal energy of the gas. So what will you do? You will multiply it with the number of molecules, that is 1.3 into 10 raised to the power of 25. Do it. 1.3 into 10 raised to the power of 25. What does your answer come out to be? What does your answer for internal energy of the gas comes out to be? 7.8 into 10 raised to the power of 4 joules. Let's further move ahead. The volume of the gas is now varied, keeping its pressure constant. Perfect. So the pressure is constant, volume is varied. Perfect. 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 Sketch the variation with volume of the internal energy of the gas. Wow. We have to sketch the variation with volume of the internal energy of the gas. If you realize internal energy is equals to what? Is equals to the kinetic energy. That is equals to 3 over 2 kT. If your pressure is constant, if your pressure is constant, that means what? Volume and temperature are directly proportional. If your volume increases, temperature increases. If your temperature increases, your internal energy increases. If your temperature decreases, your volume decreases, your internal energy decreases. This is a direct relationship. So you will draw a line like this. Is everything clear top to bottom in this question? Yes. State what is meant by resonance. State what is meant by resonance. What is meant by resonance? When driving frequency is equals to natural frequency, the oscillation of an object reaches maximum amplitude. How will you write the definition of resonance? When driving frequency equals to the natural frequency, equals to the natural frequency, the oscillation of an object, the oscillation of an object reaches maximum amplitude. Of an object reaches maximum amplitude. Let's further move ahead. A small ball is held in place using a stretch spring. Okay. Stretch string. Okay. One end of the string is fixed to a wall. Perfect. And the other end is attached to a vibration generator as shown in figure 4.1. Perfect. एक बॉल है हमारे पास वन एंड इज फिक्स्ड वन इज अटैच्ड टू अ वाइब्रेशन जनरेटर initially the vibration generator is switched off. Okay, initially the generator is switched off. Okay, a student displaces the ball vertically and then releases it. Figure 4.2 shows the variation of the displacement of the ball with time t after it is released. Perfect. So this is the variation of the displacement of the ball after time t of it being released. Now, right off the bat, I can observe some things. Right off the bat, I can observe some things. The amplitude here is decreasing. The amplitude here is decreasing. Can you see that? Can you see that the amplitude here is decreasing? What does that mean? What does that mean, beta? Amplitude here is decreasing. What does that mean? This mean it is light damping. Sir, what are you saying? I cannot understand that. Can you see these peak values? Can you see these peak values are reducing? after every oscillation. This is indicating that we are facing damping. This is indicating that we are facing damping. As your amplitude decreases after every oscillation, this indicates that we are facing damping. Perfect. Let's further move ahead. State the name of the phenomena illustrated by the decrease in amplitude of the oscillation. What is the name of the phenomena stated by the decrease in amplitude of the oscillation? Light damping. And sir, how do you know that light damping is happening? Because see, your amplitude is decreasing gradually. Gradual decrease in amplitudes. That basically shows us that light damping is happening here. Nothing complicated here. Let's further move ahead. Let's further move ahead. Explain the decrease with time of the amplitude of the oscillation of the ball. Now we have to explain why the damping is happening. Damping is happening due to the loss of energy, and loss of energy happens due to resistive forces. So you can write it like this: the resistive forces, one second, the resistive forces cause a loss in energy, cause a loss in energy. This results in a decrease in amplitude. This results in a decrease in amplitude. Perfect. Nothing complicated here. Determine the frequency of oscillation of the ball. Determine the frequency of oscillation of the ball. How can we do that? Very, very, very easy. If you realize one oscillation is getting completed in how much time? 0.25 seconds. If you realize one oscillation is getting completed in how much time? 0.25 seconds. So the time period is what? 0.25 seconds. Can you calculate the frequency? Yes. Frequency is equals to 1 over time period. 1 divided by 0.25. This comes out to be 4 hertz as your answer. Simple as that, nothing complicated. Literally nothing complicated. Let's further move ahead. The vibration generator in B is switched on. Okay, so the vibration generator is now switched on. And its frequency f of the vibration is gradually increased from 0 to 10 hertz. Sketch the variation with frequency of the amplitude of the oscillation of the ball. Okay. So how will you sketch the amplitude with the frequency? You know that the natural frequency is coming out to be what? 4 hertz. The natural frequency is coming out to be 4 hertz. So when your frequency will be 4 hertz, now let's let's locate where will be 4 hertz. From 2.5 to 5, 2.5 units are getting covered in 10 boxes. One box will cover a unit of what? 0.25. So this will be 3, this will be 3.5, this will be 4. Okay. So this is 4 hertz. At a frequency of 4 hertz, your amplitude will be, let's say, maximum here. On either sides, your amplitude will decrease like this. So this is your graph for amplitude versus frequency. Is everything in this question clear? Yes. Is everything in this question clear? Give me a yes or a no. Sir, please show part B2. दिखा देते भाई. ये लो. Here you have it. Is everything in this question clear? It is not advisable. Not advisable. Ali, it is not advisable to draw it like that. It is not advisable to draw the graph from origin, especially for amplitude. Sir, do we have to specify resistive force like friction? Wahab, if you do that, that's a plus. बेटा अगर यहाँ पे आप लिख देते हो, if someone writes here like let's say the resistive forces such as air resistance cause a loss in energy, you can write that as well. ठीक है, that's a plus. All clear? Any other questions here? भाई पूछो. Okay, let's further move ahead. Define electric field. Okay, what is electric field? What is electric field? Any geniuses in the chat? Force per unit positive charge is known as your electric field. Force per unit positive charge is known as your electric field. Figure 5.1 shows two parallel conducting plates that are in a vacuum. The plates are separated by a distance of 6.7 centimeter and have a potential difference of 430. Perfect. Your electron speed is this. Perfect. On figure 5.1, draw four lines to represent the electric field between the plates. Okay, we have to draw four lines to represent the electric field between the plates. Yeah, Wahab, you can write that definition as well. You can write that definition as well. No problems in that. Okay, you have to draw electric field lines here. How will you do that? You have to draw electric field lines here. How will you draw that? From positive to, from higher potential to lower potential. From higher potential to lower potential. From higher potential to lower potential like this. Determine the electric field strength between the plates. What is the electric field strength between the plates? E is equals to potential difference divided by distance. Potential difference is 430. Distance is what? 6.7 centimeters. So 6.7 into 10 raised to the power of minus 2. Your electric field strength comes out to be what? 6.4 into 10 raised to the power of 3. 6.4 into 10 raised to the power of 3 is your electric field strength. Simple, nothing complicated. Let's further move ahead. An electron travels at a speed of this towards the region between the plates as shown in figure 5.1. On figure 5.1, draw the path of the electron as it moves between the plates and beyond. Okay. How will the electron deflect? Any ideas? How will the electron deflect? Yes. Electron, let me do it with a different color. Electron will deflect towards the positive plate like this. And as soon as you reach outside the plate, it will again travel in a straight line. It will no more deflect. It will start to travel in a straight line like this. Because see, you have to draw the path on two occasions. If you see, you have to draw the electron path as it moves between and beyond the plates. Between the plates, it will be deflected towards the positive upward direction, and after it has moved out, it will be straight. Chalo, let's further move ahead. A uniform magnetic field is now applied in the region of the electric field. Always remember, if electric field and magnetic field are applied in the same region, where is the examiner hinting? The examiner is hinting to velocity selector. The examiner is hinting to velocity selector. And in velocity selectors, what was the case? In velocity selector, what was the case? Electric force would be equal to the magnetic force. So that the electron in B travels undeviated through the region. This is a velocity selector. Determine the direction of the uniform magnetic field. Okay. So if the electron wants to travel undeflected, magnetic force will act downward. magnetic force will act downward. Perfect. And since this is an electron, the direction of current will be opposite to the direction of the electrons. If you apply Fleming's left hand rule here, thumb pointing downward, finger pointing towards the left, where will the magnetic field come out to be? Into the page. This is your current direction. Your magnetic field will come out to be into the page. Whenever we are, whenever, देखो, very bad logic, and anyone else having this logic should remove this immediately. Whenever force is being discussed, whenever force is being discussed, we will use Fleming's left hand rule. We will use Fleming's left hand rule. Whenever current की डायरेक्शन आपने फाइंड करनी है, we will use Fleming's right hand rule. This is the distinction. There is no other concept than this. जब भी आपने करंट की डायरेक्शन फाइंड करनी है, you will use Fleming's right hand rule. Whenever you have to calculate the direction of force, you will use Fleming's left hand rule. Simple, nothing complicated here. All clear? Chalo. Let's further move ahead. Let's further move ahead, bhai. आगे बढ़ते. Is this clear? Has everyone also seen the picture on the group? देखो करंट की डायरेक्शन एज इन दिस केस के जब आपको इंड्यूस करंट निकालना हो, बेटा जब आपको इंड्यूस करंट की डायरेक्शन निकालनी हो, इलेक्ट्रॉन्स आर नॉट गेटिंग इंड्यूस्ड हियर. इलेक्ट्रॉन्स आर नॉट गेटिंग इंड्यूस्ड हियर. ठीक है, करंट यहां पे इंड्यूस नहीं हो रहा. ठीक है, ऑल क्लियर. चलो लेट्स फर्दर मूव अहेड. क्लियर है. चलो लेट्स फर्दर मूव अहेड. सो फर्स्ट ऑफ ऑल वी कैन राइट द मैग्नेटिक फील्ड इज इनटू द पेज. Explain with reference to the forces exerted by two fields on the electron why the path of the electron is undeviated. How can we explain that? The downward force due to the magnetic field cancels out or is in the opposite direction to the upward force of the electric field. You can say the forces are in opposite directions. Are in opposite directions. What will happen due to this? What will happen due to this? Hence, they cancel out, causing the resultant force to be zero. Force to be zero. Electron passes undeviated. Simple. And if you are a really good student, you can also write equal here. Opposite and equal. Equal forces are equal and in opposite direction. Perfect. Let's further move ahead. हाँ, we will use अभी. बेटा अभी use करेंगे. वहां अभी use करेंगे. Determine the magnetic flux density of the uniform magnetic field. How can we do that? We know electric field is equals to the magnetic field. Electric field का formula is what? Oh, sorry, electric force का formula is what? Electric field is strength into the charge. What is the formula of magnetic force on a charge? BQV. BQV. Q and Q cancel out. What was the electric field strength? Any geniuses in the chart? Electric field strength was 6.4 into 10 raised to the power of 3. 6.4. 6.4 into 10 raised to the power of 3. What was your velocity? What was your velocity? Do we have the velocity here? Yes. 2.6 into 10 raised to the power of 7. 2.6 into 10 raised to the power of 7. What does your magnetic flux density come out to be? Can anyone tell me? What does your magnetic flux density comes out to be? 2.5 into 10 raised to the power of minus 4 Tesla. Any ambiguities here? Perfect है? Should we move ahead? Yes or no, beta? Clear है? Easy peasy? सब easy लग रहा है भाई. Very good. Figure 6.1 shows a capacitor of capacitance C connected in series with a resistor of resistance R. Perfect. So this is a capacitance, this is a resistor. Initially, the switch is open and there is a potential difference of 12 volts across the capacitor. Perfect. Initially, the switch is open. There is a potential difference of 12 volts across the capacitor. Perfect. At time t is equals to 0, the switch is closed. So there is current I in the resistor. Okay. So there is current I in the resistor. Figure 6.2 shows the variation of current I with time t. So the variation of current I with time t is shown here. Perfect. Explain the shape of the graph. Okay. As soon as you close the switch at time t is equals to 0, this is your current versus time shape. You have to explain the shape of this graph. You have to explain the shape of this graph. How will you do that? Very, very, very easy if you just focus a bit. Okay, how will you explain the shape of this graph? Hmm. Any geniuses who would like to answer? Yeah. Discharges के लिए 3 marks देगा. Discharges के लिए what do you think? He will give you 3 marks. Hmm. What do you think will happen here? Yes. Yes, 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 yes. What do you think will happen here? Any geniuses? What can you say here? First of all, first of all, first of all, एक second. Has a decreasing gradient. Yeah, that's a property. That's a property of, you can say, the graph. How will you? Nah. Very, very ambiguous answers here. I can see 2 to 3 good answers. You have to explain why this is a decreasing curve and why this curve is decreasing in the first place. Hmm. I am giving you 30 seconds to think further. Very interesting question. You have to put the correct words here. Yes. Yes, yes, yes. Hmm. 1 second. Inversely proportional, decreasing at decreasing rate. राफे कुछ तुमने term सही यूज किए. Very good, very good. So first of all, you have to realize. First of all, you have to realize that the potential difference. 1 second, bhai. Okay. So first of all, you have to realize the potential difference across the capacitor is equals to the potential difference across the resistor. You have to realize the potential difference that the capacitor has. All of it will be provided to the resistor. You can write it like this. The potential difference of the capacitor is equal is equal is equal to the potential difference is equal to the potential difference across resistor. After time t, after time t is equal to 0 seconds, what happens? The potential difference across resistor decreases, and as the potential difference across the resistor decreases, what happens? As the potential difference across the resistor decreases, due to what? You can write it here. The potential difference across the resistor decreases due to discharging of capacitor, and this causes the current across the resistor to decrease. This causes the current across the resistor to decrease. Still, you will only get 2 marks. Where does the third mark lie? The third mark lie on explaining the fact that this is a curve with a decreasing gradient. If you draw a tangent here and if you draw a tangent here, why is the decrease in current at a decreasing rate? Very interesting thing what I have phrased here. Why is the decrease in current at a decreasing rate? Yes. Hmm. Any ideas? Yes. Any ideas why is current decreasing at a decreasing rate? You need to understand a very simple equation. You need to understand a very simple equation. What is that equation, sir? From grade 9, we have studied that current is equals to charge over time. So, as time is passing, the charge is decreasing. As time is passing, the charge is decreasing. This causes the current to decrease at a decreasing rate. This causes the current to decrease at a decreasing rate. Do you get this one? If you don't get this one, analyze the second logic behind it. What is the gradient of this graph? The gradient of this graph is current over time. Perfect. How can you write current? How can you write current? Charge over time. Since charge is decreasing, your gradient decreases. Hence, you have a decreasing curve. You can write it here, the last point. Since charge is decreasing, hence, the rate of decrease of current also decreases. Very, very interesting way to answer this question. Is this clear in its entirety? Yes. आंसर राइटिंग क्लियर है भाई. आंसर राइटिंग के पूरे पैसे दे यहाँ पे. यस. देयर इज नथिंग मोर ब्यूटिफुल देन अ गुड A2 आंसर. सर समझ नहीं आया. वेरी गुड. Wahab, what is the gradient of this graph? What is the gradient of this graph? Change in y over change in x. What is on the y-axis? Current. What is on the x-axis? Time. Current can be replaced by what? This quantity of current can be replaced by what? Charge over time. As charge decreases, the gradient overall decreases. Hence, you have a decreasing curve. I have phrased this in a word format, Nietzsche. What I have said? Since charge is decreasing, hence the rate of decrease of current also decreases. Clear हो गई बात अब. Figure 6.2. Okay, use figure 6.2 to determine what? Use figure 6.2 to determine resistance. We have to determine the resistance now. How can we determine the resistance? We are given the voltage, that is 12 volts. What is the current? What is the current? Can we calculate the current? Yes. Current can be calculated from the current versus time graph. If I zoom in here, what will this current be equal to? This current will be equal to 0.13 milliampere. So let's write this. Current is equal to 0.13 into 10 raised to the power of minus 3 ampere. What will your resistance be equal to? Resistance is equal to voltage over current. Voltage 12, current is 0.13 into 10 raised to the power of minus 3. Can anyone tell the answer to this? Yep, geniuses. Any answers to this? The answer comes out to be 9.2 into 10 raised to the power of 4 ohms. Simple as that. Nothing complicated here. The time constant of the circuit in figure 6.1. Okay, what was time constant? Time constant was the time for the current to reduce to 0.37 I naught. So what is your I naught here? 0.13. What will be 0.37 into 0.13? What will be 0.37 into 0.13? 0.37 into 0.13 is 0.048. So 0.048 is somewhere here. Yeah. This is your 0.048. What is 0.048? 0.13. That is the peak current multiplied by 0.37. At this value, what is your time constant? Let's see. Your time constant is this value. That is 4.3 seconds. Simple is this clear? अच्छा क्या कह रहे हो भाई you can also solve it like that. Beta, you can also solve it like that. No issues in that as well. Acha, we have a suggestion here, sir. Can we solve it using the decay equation? Can we solve it using the decay equation, which is something like that? I is equals to I naught E minus T over tau. Yes, you can solve it like that. Substitute a value of current, substitute I naught, substitute time T. You can easily calculate tau. So here I have done it graphically. My time comes out to be 4 point. Time constant comes out to be 4.3 seconds. ठीक है ठीक है ठीक है ठीक है. Use your answer to calculate the capacitance. Now, what will be the capacitance? We know time constant is equals to resistance into capacitance. Time constant is 4.3. Your resistance is what? 9.2 into 10 raised to the power of 4. 9.2 into 10 raised to the power of 4. Can you calculate the capacitance? Yes. 4.3 divided by 9.2 into 10 raised to the power of 4 is your capacitance. What does your capacitance comes out to be? 4.7 into 10 raised to the power of minus 5 farads. A circuit contains a power supply, perfect. A circuit contains a power supply that provides sinusoidal input voltage. There is an output voltage across a load resistor as shown in figure 7.1. Okay, there is an output voltage here. We are providing an input voltage. State the purpose of this circuit in figure 7.1. What is the purpose of this circuit? The purpose of this circuit is full wave rectification. Full wave rectification. Rectification of an AC voltage into a DC voltage. This is the purpose of this circuit. Let's further move ahead. Figure 7.2 shows the variation of the output voltage with time. Perfect. Output voltage versus time का आपको ग्राफ given है. Perfect. The load resistor has a resistance of 370 ohms. Perfect. This is your resistance. You have to show that the maximum power is this. Maximum power P max is equals to what? Voltage square over R. And voltage भी हम क्या लेंगे? Maximum V naught. So what will be your V naught here? If you look closely, your V naught is what? 9. Your V naught is 9. So 9 का square divided by the resistance, that is 370. What does your power come out to be? Any geniuses in the chat? What does your power come out to be? Your power comes out to be 0.22 volts. That's correct. Let's further move ahead. On figure 7.3, sketch the variation with time t of the power dissipated in resistor R. Very, very easy. What do you have to do? When the voltages are 0, the powers will be 0. At time t is equals to 0, power 0, 0.02 पे power 0, 0.04 पे power 0, 0.06 power 0, 0.08 power 0. So let's make these dots here. Dot, 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 and dot. What will be the maximum power? 0.22. So this is your maximum power. This is your maximum power. This is your maximum power. This is your. Can you draw a graph now? Yes. Like this. Like this. Like this. ठीक है. Calculate the mean power. What is mean power equal to? Maximum power divided by 2. Mean power is equals to what? Maximum power divided by 2. What is maximum power? 0.22 divided by 2. Your answer comes out to be 0.11 volts. Simple as that, nothing complicated. The circuit of figure 7.1 is disconnected and R is connected directly across the power supply. Perfect. Explain without calculation how the mean power now dissipated in R compares with the answer in B3. Wow, what an interesting question. What an interesting question. So the examiner is saying, now this only geniuses will be able to answer. Examiner is saying, let's leave all this garbage. We are just taking the input voltage and connecting it across a resistor. बेटा हमने इनपुट वोल्टेज ले लिया and we have connected it across a resistor like this. How will your power mean be affected? How will your power mean be affected? How will your power mean be affected? Yes. Any genius? Yes, Ali, shabash yaar, very good. Really, really happy to hear this answer. R will increase his power, increase her speed. Na, Wahab, incorrect, beta. One very good answer. Very happy to hear that. Chalo. Let's see. If you connect the input voltage directly with the resistor, what will happen? What will happen? Let's bring this circuit here. If you connect the voltage input directly with the resistor, what will happen? How will your voltage output graph look like? How will your voltage output graph look like? Your voltage output will now be a sinusoidal curve like this. Negative, positive, negative, positive, negative, positive. But what will be your power ka graph? What will be your power output versus time ka graph? It will remain same. It will remain same like this. Why? Because if you examine, power is equals to what? Voltage square divided by R. So even if the voltage is negative, even if the voltage is negative, power will remain positive. So the graph of power versus time will remain same. If the graph of power versus time remains same, your maximum power will remain same. If your maximum power remains same, your mean power will remain same. How will you phrase this answer? You will say power time graph remains same. Hence, your power maximum and mean power remains same. All crystal clear. Any ambiguities here? Yes. Anyone who thinks this is not clear, by ask right away. Sir, this is because power is always positive. Yeah, you can say that, beta. Very good, Saroshi. Very good. Very good. I didn't know whether you wrote it before, yeah, after. Like, very good. Two very good answers. Two very good answers. Really happy. State what is meant by a photon. What is meant by a photon? What is a photon? Photon is a packet or quantum of energy. Photon is a packet slash quantum of energy of electromagnetic radiation. Photon is a quantum slash packet of energy of electromagnetic radiation. Simple, simple, nothing complicated. Let's further move ahead. Figure 8.1, figure 8.1, figure 8.1 shows a tube in which X-rays are produced at a metal target. Perfect. This is a tube in which X-rays are produced. Perfect. So what do we have here? We have a filament lamp. We have a vacuum. We have a metal target. We have a glass tube. Perfect. Particles are accelerated through the filament to the target by a high constant voltage applied across terminals X and Y. State the name of these particles. We have to state the name of these particles. What are these particles? Electrons. What are these particles? Electrons. Use figure 8.1. On figure 8.1, use positive and negative signs to label the terminal X and Y to indicate the polarity of the high voltages. Okay, okay, okay. This X will be positively charged because it is connected to the metal target. Sorry, Y will be positively charged because it is connected to the metal target. X will be negatively charged because it is connected to the filament lamp. Simple. Very, very good. Very good. Y positive, X negative. Yeah, shabash. For an accelerating voltage, this is your accelerating voltage. In figure 8.1, determine the maximum energy of a X-ray photon produced at the target. Okay, okay, okay. You have to calculate the maximum energy of an X-ray photon produced. Hmm. How will you do this? Yes. For a 32 kilowatt accelerating voltage, you have to calculate the maximum energy in terms of electron volts for an X-ray photon. Yep. How will you do this? Literally, the answer will surprise you guys. The answer is so, so easy. So easy. So easy. Sure. Na, 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 na. Let me tell you the answer. So you are utilizing a voltage of what? 32 kilowatts. Perfect. And utilizing this 32 kilowatts, you are accelerating what? You are accelerating an electron. Perfect. So you have the voltage, you have the charge of an electron, that is 1.6 into 10 raised to the power of minus 19 coulombs. Can you calculate the work done or the maximum energy produced of an X-ray photon, of a single photon? Yes. Voltage is equals to work done over charge. Work done or energy will come out to be what? Voltage into charge. Your voltage is 32 into 10 raised to the power of 3. Your charge is what? 1.6 into 10 raised to the power of minus 19. Perfect. Now, you don't have to give this energy in terms of joules. This is the energy in terms of joules. You have to give this energy in terms of mega electron volts. You have to give this energy in terms of mega electron volts. So let's convert the joules into mega electron volts. We will divide 32 into 10 raised to the power of 3 into 1.6 into 10 raised to the power of minus 19 by what? 1.6 into 10 raised to the power of minus 13. 1.6, 1.6 cancel out. Let's take this to the top side. This will become 32 into 10 raised to the power of 3 into 10 raised to the power of minus 6. This is equals to what? Take this three places backward. 0.032 mega electron volt is your answer. Let's shrink some of the working. Place this here. Place this here. If something is unclear, tell me. I will clear it out. ये आ गया आपका आंसर. All clear? चलो let's further move ahead. The maximum momentum of an X-ray photon produced at the target. Okay, so we know what? Energy is equals to momentum over the speed of light. Energy is, sorry, you can write it like this. Sorry, my bad, my bad. Momentum is equals to energy over the speed of light. What is the energy? 0.02 mega electron volt. What is the speed of light? 3 into 10 raised to the power of 8. 0.032 into 1.6 into 10 raised to the power of minus 13 divided by the speed of light. That is 3 into 10 raised to the power of 8. Can anyone calculate the maximum momentum? Yep, genius is. What will be the maximum momentum here? 1.7 into 10 raised to the power of minus 23 Newton second. Simple as that, nothing complicated here. You have to calculate the minimum wavelength of X-rays produced at the target. So, do you have the energy? And do you remember this formula? Energy is equals to Hc over lambda. What is your energy? 0.032, 1.6 into 10 raised to the power of minus 13 due to mega electron volt. What is H? Planck constant 6.63 into 10 raised to the power of minus 34. What is speed of light? C. 3 into 10 raised to the power of 8. Can you calculate lambda? Yes. Genius is, can you calculate lambda? Yes, very easy to calculate. Lambda comes out to be 3.9 into 10 raised to the power of minus 11 meters. Nothing complicated here. Let's further move ahead. Explain why X-rays can be used to produce images of internal body structures that have good contrast. A very unique sort of a question. This rarely comes in the examination. This is a unique question. Why are X-rays used to produce? Why are X-rays used to produce images of internal body structures that have a good contrast? Why? Why? Because sub objects that have a good contrast have different attenuation constants. Hence, the transmitted intensities across them are very different. Hence, we can produce a contrasting image. Here you can say, Here you can say uh, good uh, internal body structures, internal body structures such as bone and flesh have different attenuation attenuation constants. Internal body structures such as bone and flesh have different attenuation coefficients. This causes different intensities of X-rays to be transmitted to be transmitted. This creates hence creating hence creating hence creating a good contrasting image. Is everything clear in this question as well? A second, let me see the chat. Very good. Yeah. Is everything clear in this question? Should we move ahead? Yes, clear है. Chalo, let's further move ahead. Now, a second. Yep. Chalo. Oh, oh. Let's move on to question 9. Define the half-life of a radioactive isotope. What is the half-life of a radioactive isotope? Time taken for the activity to half. Time taken for the activity to half. That is your half-life. Let's further move ahead. Radioactive isotope decays. Radioactive isotope X decays to isotope Y. Perfect. A sample contains only nuclei of X at time t is equals to 0. Perfect. Figure 9.1 shows the variation with time t of the number of nuclei of X and of Y as the sample decays. Perfect. Initially, at time t is equals to 0, you have only X number of nuclei. Perfect. State the name of the quantity represented by the magnitude of the gradient of line X in figure 9.1. Okay. What will be the gradient of the line here? What will be the gradient of the line here? Number of nuclei over time. Okay. What is number of nuclei over time? Number of nuclei over time क्या होता है बेटा? Activity. Very good. Number of nuclei decays over time is known as your activity. Perfect. Let's further move ahead. State three conclusions. Okay, we have to state three conclusions about X or Y that can be drawn from figure 9.1. The conclusions may be quantitative or qualitative. Use the space below for any working that you need. Perfect. The first thing that you can do here is you can see that the initial number of nuclei are what? 4. What time does it take for the nuclei to half? Let's see this. This is your time. Oh, really, really bad at drawings. I will have to improve that. Yeah, somewhat like this. This is 13.6 seconds. So the half life is somewhat around 13.6 seconds. Half life of radioactive or half life of isotope X. Half life of isotope X is 13.5 seconds. Now, we also know that the decay constant is equals to what? ln2 over half-life. You can write 13.5, you can write 13.6. It's your opinion. ln2 over 13.6, what will your decay constant come out to be? Yes, what is your decay constant? 0.051 second minus 1. So your decay constant lambda is equals to 0.051 second minus 1. What will be your third conclusion? What will be your third conclusion? If you notice, the total number of nuclei at any given point remains same. In the starting, the number of nuclei of X are 4. The number of nuclei of Y are 0. At this point, both X and Y have two number of nuclei. So at any given point in the system, the total number of nuclei remains same. At any given point in the system, the total number of nuclei remains same. And what is that total number? 4 into 10 raised to the power of 22. You can write at any given time, the total number of nuclei remain same. That is 4 into 10 raised to the power of 22. All clear up till now? Yes or no? Didn't understand 3. Acha, you didn't understand 3. Let me explain. Can you see at the starting the number of isotopes of X are what? 4 into 10 raised to the power of 22. The number of isotopes of Y are what? 0. At this point, you have 2 into 10 raised to the power of 22 of X, 2 into 10 raised to the power of 22 of Y. At this point, you have 3.8 into 10 raised to the power of 22 of Y. At this point, you have 0.2 into 10 raised to the power of 22 of X. At any given point, the total number of nuclei are remaining same. This is what I am trying to say. Is it clear now? Yes or no? Yep. Tell me if this isn't clear. The mass of radioactive अब ये वाला सवाल करते हैं. The mass of radioactive isotope in the sample in B is this. Perfect. At time t is equal to 0. Let me start the recording as well. Recording started. So the mass of sample X is this at time t is equal to 0. So 7.3 into 10 raised to the power of minus 3 kg is your mass at time t is equal to 0. And what are the number of nucleuses at time t is equal to 0 for isotope X? What are the number of nucleuses at time t is equal to 0 for isotope X? 4 into 10 raised to the power of 22. Perfect. You have to calculate the nucleon number of isotope X. You have to calculate the nucleon number of isotope X. So if I put this in correct words, at time t is equal to 0, you have a mass of this and your number of nuclei are what? Your number of nuclei are 4 into 10 raised to the power of 22. Okay. What will be the mass of one nucleus? What will be the mass of one nucleus? Let's place an X here. 7.3 into 10 raised to the power of minus 4 kg is the mass of 4 into 10 raised to the power of 22 nuclei. What will be the mass of one nuclei? X is equals to what? Yes, any geniuses in the chart. X is equals to 7.33 into 10 raised to the power of minus 4 divided by 4 into 10 raised to the power of 22. What will the mass of X or one nuclei come out to be? बेटा एक न्यूक्लियाई का मास क्या आएगा? कैन यू कैलकुलेट इट? कैन यू कैलकुलेट इट? एक न्यूक्लियाई का मास क्या आएगा? यस, ठीक है. Let's see the 7.3 into 10 raised to the power of minus 4 divided by 1.6 divided by 4 into 10 raised to the power of 22. This comes out to be 1.83 into 10 raised to the power of minus 26 kg. This is the mass of one nuclei. ठीक है, एक न्यूक्लियाई का ये मास है बेटा. But we don't have to tell the mass. We have to tell the nucleon number. We have to tell the nucleon number. How will we do that? We will take this mass of one nuclei and divide it by what? We will divide it by the atomic mass unit, that is 1.66 into 10 raised to the power of minus 27. Let's do it. 1.66 into 10 raised to the power of minus 27. This comes out to be 11 ka nucleon number. This comes out to be 11 ka nucleon number. All clear? Yes or no? And let's move on to the last question, I think, of this paper. मुझे तो last question ही लग रहा है, हाँ. I think state what is meant by luminosity of a star. Okay, what is meant by luminosity of a star? What is luminosity of a star? Luminosity is the total power radiated by the star. Luminosity is the total power radiated by the star. Luminosity is the total power radiated by the star. Explain how a standard candle in a distant galaxy can be used to determine the distance of the galaxy from an observer. So, how can a standard candle use to determine the distance of the galaxy from an observer? Yep. भाई एक स्टैंडर्ड कैंडल किस तरह यूटिलाइज कर सकते हैं टू डिटरमाइन द डिस्टेंस ऑफ द गैलेक्सी फ्रॉम एन ऑब्जर्वर? First of all, you must know that standard candles have a known luminosity. Standard candles have a known luminosity. Luminosity. And secondly, what can you do? You can calculate the radiant radiant flux intensity due to the galaxy on Earth can be calculated. Can be calculated. This is your F. What will be the last step, beta? Last step क्या होगा? Radiant flux intensity can be measured or calculated by the observer. Measured यहाँ पे better word होगा. Can be measured. Can be measured. And what is the formula that you will apply lastly? What is the formula that you will apply lastly? Apply F is equals to L over 4 pi d square to calculate D. Simple as that. Okay. चलो अब आगे बढ़ते हैं भाई. The sun has a radius of this, a surface temperature of this. Light from the sun is observed to have a peak intensity of wavelength this. Perfect. Calculate the luminosity of the sun. Give a unit for your answer. So you have to calculate the luminosity of the sun. The luminosity is 4 pi. Luminosity is what? 4 pi Stephen Boltzmann R square time की power temperature की power 4. So put 4 pi here. Stephen Boltzmann constant is what? 5.67 into 10 raised to the power of minus 8. Perfect. Into the radius, that is 6.96 into 10 raised to the power of 8 whole square, into the surface temperature, that is 5780 power 4 temperature. Can you calculate the luminosity? Yes, the luminosity comes out to be what? 3.85 into 10 raised to the power of 26 volts is your luminosity. Simple as that, nothing complicated. And other stars emits a radiation that has a peak intensity of this. Determine the surface temperature of this star. So which formula will we apply? We will apply lambda max. Temperature is equals to what? 2.9 into 10 raised to the power of minus 3. Your lambda is what? 624 into 10 raised to the power of minus 9 into temperature. 2.9 into 10 raised to the power of minus 3. What does your answer for temperature comes out to be? Can anyone in the chat tell me the answer? 624 624 into 10 raised to the power of minus 9. Can anyone tell me the answer, bhai? 2.9 into 10 raised to the power of minus 3 divided by 624 into 10 raised to the power of minus 9. Your answer comes out to be 4647 Kelvin. That is roughly equal to 4650 Kelvin. Simple as that. This marks the end of this paper.